welcome back everyone. Up next, we have CMS Shared File System with Rich again. Go ahead, Rich.
Thank you very much, Sam. Okay, here is the agenda for what we're going to talk about in this presentation. And all of these things are all part of, primarily part of SFS, the shared file system. I am going to introduce, though, why we would use SFS. So the idea is we make pools of disk space available. Now, this goes back to when mini disks were very, I want to say, limited to a volume in size. Well, a volume, when this was introduced, was very small compared to today's standards. So the reason for this isn't quite as prevalent as it once was, but it is still a very cool tool to use when in CMS. It provides access controls at the file level, which the traditional CMS file does not provide for. One writer, multiple readers to a specific directory, a hierarchical directory structure, and each user is allocated space in the pool. And it also provides storage for what's called the byte file system. The byte file system is something that James touched on yesterday in his certificate session. We'll talk a little bit more about what that is. So a mini disk allows for a finite amount of disk space and a mini disk is limited to the size of a disk volume. Now, disk volumes can be much larger today than they used to be. But so this particular problem doesn't really exist anymore. But when a mini disk is full, a new mini disk must be created, the files must be copied over to the new mini disk, and the old mini disk scratched or deleted. That is a disruptive operation because the virtual machine for which you are changing the mini disk, creating a new mini disk for, has to be logged off at some point during this process. Now, in the box here on the bottom left is a part of a virtual machine definition for someone called Rich. And he has a mini disk, and the value that's circled here is the size of the mini disk. And in this case, it's 10 cylinders. In the display on the bottom, I am looking at that actual mini disk. So this 191 device is the 191 mini disk for this virtual machine. And in this case, I'm getting, my mini disk is getting pretty full. So the typical system programmer response to this is, well, delete some files. Well, that's not always possible. So you have to negotiate to get more space traditionally, not so much anymore. But the shared file system provides a pool of disk space. So it allocates multiple mini disks, typically on different volumes. So they'll usually be full volume mini disks. Users are given access to the pool and space is allocated to each user. If the user runs out of space, the allocation can be increased very easily and non-disruptively. And if a file pool runs out of space, additional mini disks can be added also non-disruptively. So that's what makes SFS so cool, is that running out of space isn't a disruptive problem solution. Doesn't have a disruptive solution. Let's put it that way. So on the right-hand side here, this identity VMsys VPS, this whole set of text is a typical directory entry for a file pool. A file pool has multiple mini disks allocated to it, starting down here. So this 191 mini disk is traditionally the A disk, right? And optionally, we use this for the backup. When we're setting up our file pools now, we have a separate backup mini disk so that we don't have to worry about space on the A disk, and it can be quite a bit smaller. There's a control mini disk. It maps the space in the file pool. The log mini disks are used for logging activity and provides a backup mechanism for your file pool. And this catalog mini disk tracks files and directories, and this also tracks the access control information for those files and directories, who can access what. And finally, the data disk. This is where all the data is stored, and you can have multiple data disks. So the way we map these mini disks into a file pool definition is here's the mini disk, mini disks again here on the upper right, and on the bottom left is a sample from something called a pool def file. The pool def file for the file pool server maps the file pool function to a specific mini disk. So that's what these DD name statements are for. So these are specific file pool functions. The control function is this 301 mini disk, and that's what I have tagged here in this comment. The log function is 302 and 303. And I define a backup. In this case, my backup is going to the A disk. We'll talk about backups later. The catalog is 304 and the data is 305. Now, the catalog, and we're going to talk about storage groups also. Storage group numbers correspond to the sets of mini disks that where that group of data is stored. And typically you would only have one mini disk for group one, although if you have to expand it, you would allocate another mini disk. And you could have multiple mini disks. Anything other than group one is a set of data disks for users to use. And the group two can have as many disks as you want to satisfy the needs of the users. And this is kind of how it maps out. So we have this group one, which is a mini disk at 304. Group two, in this case, has two mini disks. This 305 and 306 for group two. And for group three, it has an additional mini disk. So you can have multiple groups of mini disks, and when you give access to the file pool to a certain user, you tell the file pool what group this user belongs in. And we'll talk about that shortly. So you can direct which user goes to which group. So there are two files that are used to define or configure a file pool. First is this DMS parms file, and then we talked already about the pool def file. For DMS parms, the admin directive defines the file pool administrator. So these are the virtual machines or the users that have ultimate authority in the file pool. There are certain commands that admins can issue that non-admin users can't. So if you need a virtual machine has to have ultimate control over the file pool, like in this case, our zadmin virtual machine, then you would add them to the admin list. Backup provides for automatic backup of the control data. The control data, again, is where, if we look back at our reference, control data is it maps the space in the file pool. So this is a very critical mini disk to back up, and the file pool manages that backup for us. Save seg ID, you wouldn't have to touch this. It's just the name of the save segment that contains the file pool code. And the file pool ID is the name of this file pool. It is also the name of the pool.def file. Now, the file pool ID does not have to match the virtual machine name, although I'm not sure why you would keep them, make them separate. The IBM delivered file pools, they're all different, and I never understood why. And this users directive estimates the number of users. Now, that's not necessarily the number of virtual machines accessing the file pool. And for pool.def, max users is the number of file pool users authorized to create objects, files, directories, aliases, and it's also used to calculate the size of the control area. And max disks is the number of mini disks to ever be used. These values can be typically safely made quite large. So in our case, we have them set to 500, which covers a lot of user access and mini disks in the file pool. To generate a file pool, we log on to the file pool server, format the A disk, assuming a freshly created virtual machine, create our pool.def and DMS parms files and a profile exec to start the file pool at autolog time. And we access the 193 disk. The 193 disk is where the code, the file pool code lives. And then we issue the command file serve generate, and we give the name, the file ID of the pool.def file, in this case, vmsys vps pool.def. When that command is issued, a number of messages are displayed as the file pool server is initializing the file pool, putting all the components in place where it needs them based on the values that are specified in the pool.def and the DMS parms file. And when you get this message at the end, file serve processing ended, your file pool is created. Now, it is very important to back up the control area after you create the file pool. This is not an optional thing. The file pool will require that at first startup will require that you have a backup. And if there isn't one, the file pool will not start up. So we always run this file serve backup command. We create a profile exec, and here's an example of what the profile exec looks like for the file pool server. And then we just run the exec, just enter profile on the command line, and it will start up the file pool. So very simple to create a file pool on your system. And at this point, when this ready for operator communications message comes up, we typically just disconnect from the file pool server to leave it running so that we can access it and use it. Users are enrolled in the file pool. Now, enrolling in the file pool lets a user connect to the file pool and allows access to directories and files in that file pool. A typical enroll command might look like this. I'm going to enroll user Rich in vmsys vps is the name of the file pool. A lot of these file pool commands put the file pool name at the end. So that's how we give a user access to the file pool. Now, this just lets them connect to the file pool. This doesn't mean they actually have space in the file pool. To give a user space in the file pool, we have to use the blocks option. That's what this left parenthesis, these are optional parameters to the enroll command, and one of them is called blocks. So in this case, we're giving this user 20,000 blocks of space in the file pool. To enroll a user in a different group, we can add the group option. So if there was a group 3 defined to the file pool based on the pool def um, earlier, now user Rich will be enrolled in group 3, and this space will be taken from the mini disks. The space will be used on the mini disks that are defined for group 3. Just for reference, 100 cylinders is about 18,000 4K blocks, and that's what these are, 4K blocks. So this is a little more than 100 cylinders of disk space. Oops, there we go. Now, conceptually, the file pool looks something like this. So we have the file pool up on top here, vmsys VPS, and we have a bunch of users defined to the file pool. These are top-level directories, or we also call them file spaces. So Rich has space in the pool, Tom has space in the pool, Sue, Gene, Matt, all these users have space in the pool. So their space is called a file space. In this case, under Rich has a code directory, a JCL directory, a reports directory, and Matt has his 3 directories, and under programs, he has, a directory for C code and directory for COBOL. Yeah. So the idea here is you can create this nested structure of directories underneath the file space. The nesting level is 8. And that is that's the limit that the file pool code provides for. So to access a directory, we just use the CMS access command. The first component is the file pool name. So here's an access command right here. The first part of the access command is the file pool name. And then you reference the top level directory, in this case, Tom. And if it is only a top level directory, the period at the end is very important. That's why I have the periods here, because the period is important when you're referencing a top level directory in a command. And Tom's top level directory I'm accessing as my B disk. So if I would use a file list or a list file or copy or whatever, anything referencing B will come from Tom's top level directory. Subsequently, if I want to access a level down, I would specify it after the period, the directory name after the period. So rich.reports is a directory under my file space, and I am accessing it as D. If you put a period on the end, it probably doesn't matter, but I typically don't because it isn't required. A few commands that you can issue are one command you can issue, I should say, is to set the default file pool. So if I set file pool vmsys VPS, in this case, if I go back here, if I had done that first, I would not need to specify the file pool name in any of these commands because it uses the default file pool that's set as part of the that's set in CMS. And you can actually put this in your profile exec and have a default file pool set. To set the top level directory as in a disk, so that when you bring up your virtual machine, your A disk is in the file pool, you would specify this file pool option on the IPL statement in your directory entry and specify the name of the file pool afterwards. Different pools can be accessed simultaneously. So if I access my reports directory as B, I can access another file pool, in this case vmsys U, and access Tom's top level directory in that file pool as Q. So multiple file pools can be accessed at the same time. And the vmlink command works with file pool directories as well, but you have to specify this .dir command, option to tell vmlink that it's a directory that you're trying to access. So how do we tell which directories are being accessed? There's two different commands that provide that information. Query accessed gives you this format. Query search gives you this format. Which one is better? I don't know. I typically use query search because it's shorter. You could certainly create an exec to issue these commands with something even shorter. And I've also seen variations where a lot of other stuff is added to the end of the output. So a few different ways to do this to see what's currently accessed. Some CMS commands allow a directory ID specification. So you can actually use a directory name or even a directory name in commands without having to have previously accessed that directory. So for instance, in this erase command, I'm going to erase a file called racfdata on my top level directory. The VM says vps:/rich dot, and it will erase will very happily access the look on the directory for this file, and if it's there, it'll delete it. And I can also issue a file list command with the directory name, and it will show me the files on that directory. And here's a longer example of a rename command. So I'm renaming this file smfdmpls jcl on my JCL directory to smfdmpls jcl old on my JCL directory. So a few different commands provide that capability, and you can see the individual command syntax if you're curious about a command you want to use in that way. You can display the directory hierarchy with the command called listdir. So if listdir will always show the directory hierarchy from your top level directory down. So if we had multiple multiple directories or multi-level directories, I should say, under any of these, it would show these. The file mode in this case, in this column right here, file mode indicates that the directory is already accessed as a certain mode with a certain file mode letter. It does not have to be accessed in this case. So if there are directories, if there were any other lower level directories that were not accessed, it would also display them. Here's an example from our ZVPS virtual machine. I just want to list out the directories underneath this top level directory. So it will also take a parameter with the top level directory name to display the hierarchy. You can also get it with a full screen display, and this is the dir list command. Now this does something very similar. It displays the hierarchy. It tells you what, if they're accessed, it tells you what file modes they're accessed as. But what this also gives us is F11 in this case is a file list command. So if I would put my cursor on one of these directories in the command area, hit F11, I would get a file list of that directory. And then since you're in file list, F11 would then exit a file just like it would normally would. And as we were talking before about exited macros, this is an exited macro. And as you can tell right here, we're in Xedit when we're doing this. Directory attributes are specified at directory creation. There are two different directory attributes. There's dir control, which stands for directory control, and file control, um, which stands for file control. A dir control directory works like a mini disk. One writer, multiple readers, authorization is given at the directory level, and it's suited primarily for read activity to a directory. A file control directory is much more flexible, and that I'm pretty sure that's the default. Um, yeah, that's the default. It allows for multiple writers and multiple readers to the directory, not to a file, and authorization is given at the file level. Because if two people try to write the file at the same time, you're going to have a conflict. Access is granted to a directory, and there are four types of directory access: read, new read, write, and new write. Um, why they did it this way is lost in antiquity, but the new read and new write options are for new files in that directory. And read and write are exactly what they are. So read and write of existing files. Read allows access to a directory and also to see the files and the subdirectories in that directory. Not to be able to access the files in the directory. This is just for the directory itself. New read implies read and allows the user to see new files or subdirectories. Write implies read and allows the user to create new files. New write implies write and allows the user to write to new files. So to give a user full access to a directory, we would grant auth is the command to do that. And we specify the directory name, and we're going to give the access to Rich. So I'm giving Rich access to Tom's top level directory. And I'm giving Rich new read and new write access. New read and new write include everything underneath them. So this is complete access to anything that's currently there or anything that is created after the grant command is issued. To grant a user read access to a directory, we just specified new read. So what this means is all the existing files are granted, and in addition to any new files. So in this case, I'm granting auth to rich.jcl to Tom. So Tom now has read access to my JCL directory. That's how we read this. There are RACF controls for SFS, but I don't know that anybody has ever used them. We never have, that's for sure. Access could also be granted to a file or files in a directory, and there are two types of access. In this case, thank God, just read and write, as it should be. So read allows you to see the contents of the file. Write allows you to change the contents of a file, rename and erase a file, but it requires write access to the directory in order to do so. So read access to a file is granted like this. So with grant auth, the first two terms, the first two parameters are the file name and the file type. The next parameter is the directory name, where that file exists. And then the rest of the command is the same. So I'm granting this access to Rich with read authority. So the Rich user can read this COBOL program, bad code COBOL, on Tom's code directory. That's how we read this. To grant all access to a file, we just specify write. because write implies read. And in this case, we're granting the access to this file, good code C, to um, Tom on this rich.code directory. To grant access to all files in a directory, which is much easier, instead of a file name and file type, you specify asterisk and asterisk space asterisk. So in this case, we're granting authority or to read authority to Rich for all the files, asterisk space asterisk, in the mat.reports directory. So in a nutshell, that is how we grant access to files. This by far is much easier than picking and choosing what files you want to grant access to. Enrolled users also have access to something called a public area, and directories or files are granted to public. So in this case, I'm granting off to public to mat.reports. And this is a directory, this isn't a file. A new read means any existing file and any files added after the grant is issued. And anybody that is enrolled in the VMsys VPS file pool now has access to read the reports that Matt creates because it says public. So public means everyone. You don't have to do specific grants to users. It's public. To allow any virtual machine to connect to a file pool, there's a special user called public that you can enroll. So we enroll public in VMsys VPS. So any user on the machine can now connect to the file pool and subsequently would also have access to Matt's reports because it is also granted to public. The grant authority command is used to allow users to access files and directories. It can be issued by the administrator of the file pool or the owner of the directory. Grant authority is reversed with the revoke authority command. And admin authority is granted to users listed in the admin statement in the pool def file, or users listed in the enroll admin command. So we enroll admin Rich, and now Rich is an administrator on whatever the default file pool is when this command is issued. If I want to specify a file pool name, I can do so after Rich, like we did earlier. Now, this enroll admin is a temporary operation, meaning if the file pool server is restarted, Rich loses his admin access. In order to make that permanent, he has to be added to the admin statement in the pool def file. Okay, let's talk a little bit about space management. When you're using a file pool, you might get messages like this: storage group 2 is short on storage, or storage group 2 is full. This first message will be issued as it starts filling up, and the second message is kind of the danger zone. This 3202W, this short on storage message, is issued based on the group thresh parameter in the DMS parms file. So there's an additional parameter you can specify to indicate when the group threshold is reached. And the default is 90%. So you can change that if you so desire in the DMS parms file. To check mini disk and storage group space, there is a command, query file pool mini disk. And if you give it a file pool name or just let it default, it'll display all of the storage information about that file pool. And what is interesting here is this storage group mini disk information section tells us exactly how full some of these mini disks are. So the second column here is the mini disk number. The first column tells us what storage group that mini disk belongs to. So if I'm looking at, storage group two, it has one mini disk and it is 26% full. And it has just under 400,000 blocks free. If I look at the storage group totals, this groups it by storage group specifically without the intervening constituent mini disks. So this is probably the best place to look for it because we can see exactly how full a specific storage group is. And there's also information in this output about the logs. We can see how full the logs are currently and the control mini disk. For file spaces, if you're filling up a file space, you might get this warning message. The file space threshold has exceeded for a specific file pool. This indicates, the second message indicates that the file space is pretty much full. Now the threshold is set, I think it's set in the enroll command, I believe. I usually don't set it, I let it default. And that is to display the file space allocation. You can issue the command query limits, the keyword for and a user, or just query limits will display your file space if you have a file space. And this tells me the user Rich is in storage group 2, and his file space isn't very full. It's only 0%, only 18 blocks. That's what this number indicates out of 2,000 is in use. And the threshold is 90%. And all the thresholds we just usually leave at 90%. If you issue the command query limits all, that will display all the users in the file pool and how full their file spaces are. So we can see from this list that the highest one is this zweblog file space with 65% utilization. To control file space allocation, again, what we displayed, talked about earlier, when you're enrolling a user, you give a user a certain number of blocks. And in this case, we're giving Tom 2,000 blocks of disk space. You can increase or reduce the file space allocation dynamically. And this is one of the cool features about shared file system. So in this case, there's a modify command. And this, I think the syntax here is kind of backwards, but the modify command, the modify user command, I should say, you're adding 1,000 blocks for Matt. So what this will do is this will increase Matt's file space allocation 1,000 blocks. So whatever it was before, we're going to increase it by 1,000 blocks. And we don't like that Tom is using a lot of space in the file pool, so we're going to reduce his allocation by 500 blocks. So if he's in danger of filling up now, he really will be, and we'll have to delete some files. To delete a file space, we just issue the delete command and the name of the file space. So Gene, sad that Gene doesn't work for us anymore, maybe, we delete her file space. So that file space is recovered and used for, or can be used for other things. To add space to a storage group, there's a few different steps. We add a mini disk to the file pool server virtual machine. we create a file describing the new mini disk, and we issue the file serve command to expand the storage group. So it's a multi-step process. So adding a mini disk to the server is what is typically what you would do to add space to any other virtual machine. So we add this mini disk, we're going to call it 307, and in this case, it's 500 cylinders. So we're going to add 500 cylinders of space to the file pool. That's the ultimate goal here. So that's what this mdisk statement provides for. We create a file to describe the new mini disk. So on an administrator user ID, we're going to create a file called, we're just going to call it new 307 pool def A. That's going to go on the A disk. And in this file is going to be this DD name nomenclature. And the DD name value has to be one greater than the existing MDK value that is existing, that's currently in the file pool. The virtual device number is 307. That's the device number we added to the directory entry for the file pool, and we're going to make it group 2. So group 2 is going to be expanded in this case. We have 2 group 2 mini disks. We're going to create a third one. The next step is expanding the storage group. So once that file is created, once the mini disk is added, we link to mates 193, which is where the file pool server code is located, and we issue the command file pool mini disk. In this case, the file pool name is inside the parameters as opposed to at the end where most of these commands are. This is the file pool we're increasing the size of, and then we give it the name of the file that we created back here with this that only contains this DD name, this nomenclature right here. The file pool is going to verify that the disk exists. It's going to format it and prompt you to verify that you actually want to format it. And when it finishes, it will put a message in your virtual reader, which indicates that the function is completed. And when it's done, you can use that new space. So that new space is automatically available. We didn't have to restart any servers. We didn't have to bring down the file pool server. This is a non-disruptive operation. That's the other thing that's really cool about SFS. Okay, we're going to talk about backups and recovery. There are 2 different types of backups, control data backups and user data backups. Control data backup backs up user allocations, authorizations, storage group 1, the control disk, and the pool def file. Control backups are automatic when the log's full. So remember those log disks? It logs activity to the file pool server. When one of those log disks fills up, the log activity switches over and a backup is triggered automatically. You can do a backup explicitly with this command, file pool control backup, and that will back up the control data. But control data backups are pretty automatic. And if your file pool is really active, control data backups might happen fairly often. For user data backups, we can back up files and directories that users create. There are 2 different types of backups. There's a file pool backup and file pool unload. Both are administrator commands and can be issued concurrent, usually concurrent, with file pool operations. And I say usually because if there is a user that has an exclusive right to a file space, a backup may fail, and we have that happen quite often. Um, when we're doing backups. So typically I run these backups late at night, and I do backup our file pools pretty much every day. So file pool backup can be used to back up a storage group. Remember, a storage group is a collection of mini disks that users store their data in. A file def command, now this is a new CMS command, a file def command must be issued to define the backup file. If you're a ZOS person, think of this as a DD statement in your JCL. But we issue this file def command to define a file called backup, and we're going to write it on disk. And there is definitely a tape option, because back in the day we would write these backups to tape, but now they're mostly on disk. And then after that, you give the file ID of the backup file. So the backup is being written to this file, VMsys VPS backup 2, in this case on the D disk. And then we issue the command file pool backup 2. 2 references the storage group. So we're only going to back up storage group 2 in this case. If there was a 3, you could back up storage group 3, etc. To restore from a backup, this restores a storage group. A file def must be issued to define the file that contains the backup. And in this case, the file def points to a restore file on disk, and it's the same file name that we backed up previously. And in this case, we issue the command file pool restore to, and that will restore the entire storage group. Now, this will wipe out any changes that may have taken place between the backup and the restore. So you have to be very careful and very deliberate when you want to do a restore like this of an entire storage group, because that could change a lot of users' file spaces and files. Probably much easier is to restore an individual file from a backup like this. And you can certainly do that with a storage group backup. In this case, we have to create a file containing the list of files to restore. And that file has to have the name control file load A, or control file load. It doesn't have to be on the A disk. to And inside the file, you specify the file name, the file type, and the directory name that you want to restore. In this case, here are a couple of examples. I'm restoring a file called install log on this ZVPS top level directory, and this file called zmon, and this date, that's a really old date, on the zvps.consoles directory. The file def must be issued to define the backup file, just like we did with the storage group backup. We define the restore pointing to disk. This is where our storage group backup is located. To do the file restore, we issue the command file pool file load to. So in this case, we're going to restore, it's going to find this file and look for these files in these directories on the backup and restore them into the original, in this case, the original storage group 2. Now that's different than this command, file pool restore, which restores an entire storage group. So make sure you know that there's a difference. File load will restore individual files. Restore will restore the entire storage group. There's another command called file pool unload, and this is used to back up a storage group or a file space. So you can back up individual user file spaces with this command. And a storage group file space or individual files can also be recovered from this command. A file def must be issued just like always. So we're going to issue our file def, and in this case, it's called unload. It's pointing to disk, and this is the file name that we're going to unload our storage group or our file space to. And we issue command file pool unload group 2, and this will unload or backup the file the storage group, in this case group 2, to this file. Consequently, we can also unload a file's individual file space. So in this case, we're going to unload file space rich, and it's going to go into this file. So if you don't want to back up, excuse me, individual storage groups, you can back up. If you don't want, I should say, if you don't want to back up storage groups in mass, you can back up individual file spaces as well. But each file space backup will have to go into a separate file, because otherwise you just overwrite file spaces if you use the same unload file def. To restore from an unload, again, you can restore an individual storage group. We define the reload file in this case and point to our backup, and we can reload group 2, which will also overwrite the entire storage group. So the same problem, the same problem from before. To restore a file space, a file def again must be issued, and the group option on the reload can be used to move a file space to a different storage group. So if you have a user, for instance, in group 2 and you want to move them to storage group 3, you can do that without having them, copy their own files. You just take a backup and do a reload specifying the different group, the new group number, I should say. So with the reload option, we specify file def with the reload file and pointing it to the file space that we point it to the backup file, and we use the command reload file space user rich. And rich is the file space we're going to reload in this case, and optionally we can give it a different group number. So like I said before, if rich was in group 2, we could move him to group 3. And also unload, we can restore individual files from an unload. So very much like before, we create a file containing a list of files to restore. In this case, the file name is control reload. And it works exactly the same. File name, file type, directory name. We issue the file def for reload, pointing to our backup, and then file def reload files, and it will look for this file and restore the files to their original directories. All file pool commands require access to the 193 disk. It's very important. Backups and restores can use tape. Like I mentioned before, there are a lot of usage notes tied to these commands. So make sure you read them and understand what's going on. Okay, we're going to talk a bit about the byte file system. Now, James touched on this in his certificates session yesterday. I'm going to go just a little bit deeper, talk about what this is all about. There's a component in CMS called open extensions, and they've changed the name quite a bit. I'm not sure if that's still the right name or not, but they've changed the name a couple of times. It implements POSIX standards under CMS. Now, this was written mid to late 90s when the idea was to bring some of this Unixy function to VM. But once Linux came out, all that was pretty much abandoned. But these are the POSIX standards that are implemented, including a POSIX compliant file system. Also shell and utilities, which is very cool on CMS. And it was traditionally used to port Unix features from ZOS to ZVM. Think LDAP, SSL, MP route, and I think that's it. So the POSIX compliant file system is stored as a file space in the shared file system. So it uses the exact um, file pool that we would define, but you just give it, you just tell it it's a BFS file space, a byte file system file space. It's a byte stream. You can have long file and directory names. I think the limit is 255. Many possible directory levels. You're not limited to 8 like you are with SFS. Unix style file permissions, and a Unix command set. So this is basically a Unix subsystem-ish in CMS. The shell and utilities component provides a command line interface to run open edition programs, environment variables and aliases, shell script programming, manipulating BFS files, and there's a few ported applications that are quite long in the tooth by now, and some development utilities. So to create a BFS file space, you enroll a user with the BFS option. So that creates a MAT file space as a BFS, it creates MAT as a BFS file space and gives him 20,000 blocks of space. To specify a BFS path in a CMS command, and James touched on this a little bit in his presentation, there's this qualifier, this identifier that tells the command that it's a BFS file space that you're dealing with. And you provide the file pool name and the name of the file space. In the case above, the file space would be MAT. It references the MAT file space in BFS. So to interact with BFS, there are a number of CMS commands that allow you to do so. These are all CMS commands. These are not shell commands. These are all CMS commands. James touched on a few of these in his session yesterday. And what is also very cool is there's this shell option that starts an actual Unix-like shell in CMS. And we will show that right now. So we issued the command, the OpenVM command with the mount option. So we're going to mount this root file system that should already be defined on your CMS system. And we're going to mount it as slash. So when we go into the shell, this root file system is going to be the actual root. So this works very much like a mount command in Linux, except the syntax is a little different. And we issued the command openvm shell. It actually fires up a Unix-like shell in CMS. So if you're familiar with Unix or Linux, you'll recognize the prompt down here, the # prompt. You are literally now in a Unix environment. The pwd command, print working directory, shows you that you're at the root. And here's ls-l output, which shows you the listing of the root file system. In this case, some of the things that are mounted in different directories already, but some of them that exist under root. Lots of other commands are available. I'm not going to go through this exhaustive list, but yes, you can definitely have, it is definitely a Unix type subsystem. A number of different tools have been ported. Gzip, numake, syslog, LDAPD before VM had LDAP available, and even Apache, a very, very old Apache. There is a red book. It might still be available. I actually have a hard copy. Porting Unix applications to Open Edition for VMESA. This was primarily written by Neil Ferguson, and Neil did a lot of porting of these packages to the Open Edition environment, and he discusses the process that he used. On the IBM website, there are a number of different tools that have SFS type components to them. This is just a list from a few years ago. I don't know if any of these have been updated. I haven't checked, but there's a lot of different tools here that are utilities for SFS systems. And a little bibliography. Here are some of the books that you could look at in the ZVM library for information about the shared file system, this file pool planning, administration, and operation. That's the biggest one in this case. And there is actually an open extension shell and users guide manual also. And that is the end of my prepared presentation.
All right, thank you, Rich. Well, that concludes our ZVM training. Thank you to everyone who participated. All homework assignments will be due on July 29th, which is 1 week from now. Certificates will be sent out upon completion of your homework assignments. We will also be sending out a survey, so please fill that out so we can get feedback. I hope everyone found this class to be helpful and learned something new. And once again, thank you all for attending.